Hello, responders. I'm your host, Isaac Alatorre from Portable Pipeline Systems, and today we have another small but still relevant job out of South Tahoe Public Utility District in California. So great special thanks to Aaron Zook, who was the one who was supervising this job out in South Tahoe Public Utility District. And also I want to thank the publicity department for allowing me to share it. So without further ado, let's get started. This will be a brief job, but still I think there's a lot of great points we can learn. Okay, so just to start, this was a planned construction for a stationary pressure reducing valve that was getting updated and replaced. Now, they were going to jump hydrants on this, and we're going to get into the details about that. Let's start with the fire hydrant, the upstream fire hydrant. There was a small gate valve on the upstream fire hydrant to start. Then they used 130 foot by 2-inch NSF hose to connect to the downstream fire hydrant, which they jumped over kind of like a rural area, as you see here in the pictures. As you can see in the picture here, this is where the temporary PRV was placed. Now, unfortunately, they had a box, covering this PRV, so you can't really see it. They had to. I think they did that for security reasons. They didn't want anybody messing with it, which I think is a great idea. I always tell people in other previous videos, out of sight, out of mind. People are not going to mess with something that just looks boring. So I understand why they covered it, but unfortunately we don't know. We don't have a picture of it. But they did give us what they used. They used an Oxford Flow carry flow model, which I have done a previous video on. Actually, just was coincidence. I did not sell him this. He had on his own. And I'll put a link in the description of the video I did. I actually tested this PRV. It is great, guys. It weighs practically nothing. You can carry it with your hands. It reduces pressure so easily. And it's just a great piece of machinery when you compare it to other PRVs. I think anybody who handles high pressure situations should definitely get one of these carry flow Oxford PRVs. They're great. So back to the case here. They started with 87 psi and they used the PRV to reduce down to 54 psi just to make it more manageable, I guess. That was what Aaron told me on this job. And also then on the downstream hydrant, as you can see here in the photo, they used a fire hydrant backflow preventer meter. So this is basically the job that they had, and it only took 2 hours to complete. It was out there for 2 weeks with no problems. Security was not an issue, like I said before. But again, this was not a busy street, so they had it pretty good here. No pressure issues for customers, and they did have a small leak from the PRV, but it was so slight that they didn't even have to worry about it. It didn't even leak onto the street, so pretty easy, pretty manageable anyway. So yeah, so there you have it. This is the job. And I thought they did a great job. Okay, guys, that wraps it up. Like I said, very brief job. I hope you guys learned some things, especially about the PRV. I think it's great to use a PRV if you have high pressure zones. That just because it's safer, it just makes it easier on your guys on the field. Again, please follow me I'm on LinkedIn. I'm also on Facebook. I also have an email newsletter if you'd like to learn more about these case studies. And if you're using NSFOs, even if you don't buy it from me or you just want to share it with the community, please reach out to me, and I would love to share your case with the water community. Okay, so like I always say, be safe and think ahead, guys, and I'll see you in the next video.